Hello everyone, welcome back to my channel again. Now I'm going to share with you some of the test results of GPT-4o and GPT-401, two models. So on the left hand side, we have the GPT-4o model. On the right hand side, I have the GPT-401 model. So I see a lot of online comments, analysis about the new model. There are some assumptions about how this model is different from the previous version. Basically, one assumption is that it has a chain of thought. The chain of thought, we have seen it in the prompting engineering, is a technique to guide the large language model to follow a reasoning process when dealing with hard problems. And there could also be the chain of thought in the agentic workflow. So now here comes the second assumption that the new model actually has an agentic flow in the backend. So there are some agents to organize the workflow and to provide a more detailed response. So at first, you can see on the left-hand side, the GPT-4 model will just break down the different approach first to suggest the approach and also give a sample code for front-end visualization. And yeah, I say I want to build it. It will give me more guidance on how to run it in Collab. So I'm not going to evaluate the intermediary results like this one. Okay, I'm going to go straight forward to the end. So basically, as you can see here, my prompt is to build an app to dynamically show the neural network working process. Okay, so it said that there are some features. I'm not going to every sentence it says, okay? But eventually, here, the first workable result is this sample code. And I say, okay, please help me build it. And I want to use Jupyter Notebook, okay, because I want to run it in my Collab environment and also local environment. And here it goes to install dependency and so on, like the routine job. Okay, also give some the detailed code. Okay, so also next step suggestions. So let's now see how the GPT-401 works. I give the same prompt, but when I gave the first prompt, it actually breaks down this. It's called a reflection. In my interface is in Italian because of my geolocation. But I can see it's like internal recursive thinking process. Part of it is breaking down this task and also to build a chain of process. So either it's a chain of thought design or agentic workflow design. It works well and make sure that there is a plan to go. Okay. So let's see, clarifying the request. Okay, mapping out the request to an app to dynamic blah blah blah. Pulling together suggestions. Okay, and highlight the visual aids. I actually understand when I said dynamically to show this process so it understands correctly. Evaluating options. Okay, it's good. Then assessing neural network tools. Yeah, so it said deep background of interactive visualization. So it's still checking if different tools will meet my demand. Eventually, it will evaluate the options. So I'm not saying that it will evaluate everything in the end, but in every step, you see there are some checking. So I would suppose that in each step there is an evaluation process to actually make sure that each step is more cohesive. Okay, can work in more streamlined model, streamlined way to the end. So let's see. It actually says, okay, if you're interested in the app, dynamically show the work. There are some options. Yes, of course, I know there's a playground of TensorFlow. And also there are some useful websites for me to try. If you are interested, please try it because some of the playground I think is built very well to help you visually understand the neural network. And also it suggests, of course, educational website. Okay, they have a very good educational resource. And consideration for the app. Okay, it just gives some simple suggestion. So I would say it will give a more approachable, more easier way to get what I want. So I can use these third-party resources. Then it gave me some indication how to build the app. Okay, so it makes sense, right? So instead of spending a lot of time to build the dynamic display of neural network, why not use third-party resources if you want to learn something? Makes sense. So let's see here. Yeah, I say help me build it, so it starts to building it, and the dependencies and so on. And you can see it actually breaks down to different steps. I mean, if you change your prompt, I'm sure the result will change. For example, you want the model to give you one code block instead of individual blocks. Okay, but here I think from a learning perspective, it helps me to learn this deep learning algorithm very well. So it breaks down to say, okay, these are the activation functions, and define a neural network, create interactive widgets, and so on. And okay, here is the first time we display the interactive plot. So it keeps on going. Okay, here we already see some results. I'm going to show you in Collab later. Then it says visualize a multi-layer neural network. So it goes one step beyond. As you can see, these all functions are about a two-layer neural network. So previous one, we could assume that it is about a one-layer neural network. Okay, so it goes on and on, just increase the complexity of the code. Then we see here, it actually is saying visualizing decision boundary, one of the important concepts to visualize. Yeah, it actually expand to different secondary topic like decision boundary, right? Let's see. Okay. And enhancing the user face. So eventually, after displaying one layer neural network, two layer neural network with all different activation function and setup, then it goes to the decision boundary. Eventually, it goes to user interface. User interface enhancement would be very important to help the users to see. Later, you are going to see how it is enhanced. And eventually, there is an additional option to turn it into an app. This is out of my expectation. Okay, so now let's check. On the right hand side is the code, left hand side is the Viola app. Okay, so let's go through the notebook first. First of all, this is the GPT-4o version. You see here, we can have the display of the neural network. Okay, and also here you have the second option. You have a run button to run the forward pass. Okay, it's called a run forward pass. It's just to simulate the neural network for you. If you run this code, you can change it. It will produce a new picture after it. Okay, so basically it works. Okay, and I just reconnected to my runtime just to show you. You see when I change the input, it's called input neuron, hidden layer, hidden neuron, sorry. And you can see each time you click a different parameter, you have different neural network, right? So output neuron, let's say we have 5. Yeah. So this is a neural network with one hidden layer. It simulates very well. Then we see the part 2. As you can see here, when I click run this part of the code and click the button run forward pass, there's nothing shown. Okay. So I finished the part about the GPT-4o. Now let's check GPT-401. Okay, so we need to install the different dependencies. Okay, and this function does not work. I just skip it. Okay, this line does not work. I skip it. And as you see the result from GPT, okay, I pasted everything here. I just rerun the code to make sure it works. Now let's see. You change the weight. Actually, the sigmoid function changed its shape, and when you change the bias, okay, so it just shows you that how the activation function will change in shape, so you can have you would have different outputs. Okay, and if you change the activation function, you are going to see different results. Works very well, and you see it does not just create another graph. It actually changed the original graph, so you can see it dynamically. Looks good. So let's keep going on to see the more complicated way. So this is a two-layer neural network. If we change weight 1, bias 1, the activation function change. We change weight 2, bias 2 of the second layer. Yeah, looks good. And if we change to another function, yeah, looks good. I mean, looks good, it works, when I change the parameter. But if you really want to 100% to match to a specific model, to actually know the calculation result is 100% correctly displayed here, review all the code. Okay, now I just quickly go to the next part. Always pay attention to the different packages, because in Collab environment, some packages are defaultly installed. If you are going to run it in a local environment, you need to install some of the packages. So let's go on to the next part, decision boundary. So basically, decision boundary is very useful in the classification problem, because in the boundary it is a fuzzy area, I would say, because you cannot separate the two, let's say, two items, okay, or two objects, okay, because let's imagine it's an object with different traits, different features. On the line, you cannot separate them correctly, or you cannot see much difference between two groups. The further away from the decision boundary, the more clear the picture it is. You can separate the data points to different groups. Yeah. So whenever we change the parameters, then how the data is fed to the activation function and create such a decision boundary. You can see it in this graph. Then let's go on. Let's see. Yes, in the later part, we have a two widgets choice in the same output. You can see here, if I change here the weight 2, actually weight 2 on the upper hand side also change, okay? It gives me more flexibility of manipulating this display. Looks good, okay? Only issue is that in Collab environment, you cannot initiate the Voila app. So let's switch to the local machine to see if the app works. Now let's take a look at the results in the local machine. On the right hand side, I open the notebook. On the left hand side, this is the result when I launched the Voila application. One thing I need to mention is that you see the notebook I saved in Collab cannot be directly run utilizing this application, because let's see in the end, it's very important that whenever you run this notebook, you input this command in the terminal. It is going to run all the code blocks in the notebook. So like in Collab, let's see this original version. If we are going to run it, it will go through each block. So if some of the code is going to run well in the Collab, it will not certainly run well in the local machine. So always pay attention. So I created this clean version. I just delete the unnecessary reinstallation of the packages because I already installed previously. Okay. If you run it for the first time, of course you can put it here. But if you run it the second time, it will go through the installation again. It may drag down your runtime. Okay. Increase your runtime and drag down your efficiency. So as I cleaned up this notebook, I delete or I canceled some of the unnecessary parts. Okay, so the app will run through every block. Okay, we can try to refresh it here. So I think I need to restart the Viola app here. Let's restart here. So now we inserted the correct command, Voila, with the notebook name. Okay, the clean version, of course. And we click enter. It will start running the code. As you can see, it will open the browser. I'm going to close the previous version. So as you can see here, it will execute each code block one by one. So again, important thing, because I already modified a lot of things in the clean version. So basically, I canceled all the installation of the package if I already installed. I canceled some of the unnecessary confusing code, like the code to be run in Collab environment, right? Canceled everything, and this app works to execute all the code that can be run locally. Okay, and you can see here, it will also give you some of the indication like this one. This notebook is not trusted. Okay, and so on. So let's wait for the final results. It will execute each block one by one and eventually show the results. And after refreshing several times, I get the result on the left hand side. So one suggestion, when you see the left-hand side stop at a certain step and you are sure the code has no problem, refresh, you are going to get a result. So basically this app has shown everything that we have seen in the Collab notebook, and you can see it is very user-friendly. Okay, you can change the different parameters. You see the activation function, the change of the result. Okay, so one important thing, remember the activation function, okay, is going to take the weight and bias calculation results and provide this output. Okay, if you are interested to dig into the different activation function, please check their theory background. It is very useful for you to understand neural network. Okay, so let's back to focus on the app itself. Okay, you can manipulate everything, and you are going to see the different result here. It is very clean and well designed. Okay, I'm going to say I'm really surprised about the new model for this specific task. But as I see, some of the OpenAI employee already published in Twitter. They said we cannot expect this model to perform always better than the GPT-4o because on some specific task it may be inferior. Okay, I have not yet tried those kind of tests. If I find anything, I'm going to share with you in the future episodes. Okay, so basically, quick wrap up. So today we tested the GPT-4o and the GPT-401 two models to do the same task. Of course, GPT-4o has some working code, but the overall performance GPT-401 get a more robust design of the whole process and to really break down the task and provide a working code, and it works very well. Okay, this is a quick wrap up. Please try this model, and if you have any question, feel free to ask me. If you like my video, please subscribe and see you next time. Bye bye.